On April 26, 1986, the world saw a disaster that completely changed how we think about nuclear power. Today, we're going to pull apart the chain of events that led to the Chernobyl catastrophe. It's a story that really kicks off in the last few frantic moments inside reactor number 4. So picture this. It's 1:23 in the morning. You're inside reactor 4 at the Chernobyl Nuclear Power Plant. A safety test, something that's supposed to be routine, is about to go catastrophically wrong. Right in these moments, workers feel the whole building start to shake. That's the first sign that the nuclear reaction deep inside the core is spinning wildly out of control. The explosion that followed just unleashed a torrent of radioactive material into the sky. And to really get a sense of the scale here, the fallout was equal to 400 Hiroshima atomic bombs. It was a nuclear event unlike anything the world had ever seen. And it all started with someone pushing a single button. Okay, so what exactly happened in that critical moment? You've got alarms blaring, the reactor is literally shaking itself apart, and a worker does the only thing that makes any sense. He slams the emergency shutdown button, the AZ5 button. It was designed to stop the reaction cold. And this, right here, is the central, heartbreaking irony of Chernobyl. The one button that was supposed to save everyone did the exact opposite. Instead of hitting the brakes, it was like flooring the accelerator, and it triggered a massive, massive blast. But why? How could that even happen? Well, to get that, we need to pop the hood and look at how these reactors actually work. To really understand what went so wrong, we need a super quick science lesson. At its heart, a nuclear power plant is just a really, really complicated way to boil water. The heat from a controlled nuclear reaction makes steam, that steam spins a turbine, and that generates electricity. It all gets started with a little process called fission. At the center of everything is uranium-235. It's an unstable element. And when a tiny little particle, a neutron, smacks into its nucleus, the whole atom splits apart. Now, this split releases a huge amount of energy as heat. But the really important part is that it also shoots out more neutrons. And those new neutrons, they're the key to the whole thing. They fly off and hit other uranium atoms, which then split and release even more neutrons. And this creates a self-sustaining chain reaction. The whole trick, the entire challenge for a nuclear plant, is keeping this incredibly powerful reaction under perfect control. So, the easiest way to think about all this is to imagine the reactor is a car. The uranium fuel rods, that's your engine. Now, to make the reaction go faster, you need something called a moderator. At Chernobyl, they used graphite. Think of graphite as the gas pedal. And to slow things down, you use control rods made of boron, which act like the brakes because they absorb neutrons. Okay? This is the key thing to remember. Graphite is the gas, boron is the brake. This is going to be really important in a minute. So, let's get back to the night of the disaster. The crew in Reactor 4 weren't trying to be reckless. They were actually running a safety test. But here's the thing. This test had been tried on other reactors before, but it had never once actually succeeded on this particular one. And the goals seemed pretty simple. They wanted to see if, during a total power blackout, the leftover momentum from the spinning turbines could power the emergency water pumps for just the 60 seconds or so it took for the backup diesel generators to fire up. The whole test was designed to make the plant safer, but a whole string of mistakes turned it into a ticking time bomb. And this is where everything starts to completely unravel. You have this perfect storm of human error, delays, and a catastrophic design flaw all coming together at once. It started with this sudden, totally unexpected drop in power. As the test was getting started, the operators were supposed to lower the reactor's power down to about 700 megawatts. But instead, the power level just plummeted. It crashed right past their target, all the way down to just 30 megawatts. The reactor was barely even running. The operators had no idea what was going on. They just knew the reactor's core was being, silently poisoned. It's a phenomenon called xenon poisoning. The best way to think of it is like smoke from a fire. See, during fission, a byproduct called xenon-135 gets created. This gas acts like a wet blanket, just smothering the reaction by soaking up all the neutrons it needs to keep going. At such a low power level, the reactor couldn't burn off this xenon smoke fast enough, and the core was basically choking itself out. So, desperate to get the power back up so they could run their test, the shift supervisor makes this terrible decision. He orders the operators to pull out most of the control rods, the brakes. They pull them out way past the minimum safe limit, leaving only 8 in the core when the rules absolutely demanded at least 15. This was a massive violation of safety protocols. So with the brakes pretty much gone, the reaction starts to surge. The operators panic, and they finally hit that emergency shutdown button. And this is it. This is the fatal flaw. It was a flaw born from a Soviet design philosophy that often put cheaper production ahead of safety. The boron control rods, the brakes, they had graphite tips. And remember what we said graphite is? It's the accelerator. This meant that for a few horrifying seconds, when they hit that emergency button, the accelerator tips entered the core before the brakes did, causing this instantaneous, uncontrollable power surge. The result was absolutely catastrophic. In a flash, the reactor's power shot up to over 33,000 megawatts, many times its design capacity. A huge steam explosion blew the 1,000-ton lid right off the reactor core, and then just moments later, a second, even bigger explosion ignited all that graphite, sending a plume of radioactive fire miles into the night sky. But those explosions, they were just the beginning. What came next involved unbelievable heroism, a massive government cover-up, and consequences that would ripple across the entire globe for generations. The initial response was just chaos and incredible bravery. First, firefighters rushed in to fight a fire they couldn't possibly understand. A few days later, 3 engineers volunteered to dive into a pool of highly radioactive water underneath the melting core to drain it. They knew it was a suicide mission, but they prevented a second steam explosion that could have made most of Europe uninhabitable. And then came the liquidators, hundreds of thousands of people sent in to clean up a lethal mess. The human cost was immediate, and it was devastating. 28 of those first responders died, just horrific deaths from acute radiation sickness. Thousands were forced out of their homes forever. And for 2 whole days, as these radioactive clouds drifted towards Sweden, the Soviet government said nothing. It was a total cover-up that only fell apart when the rest of the world started detecting the radiation. The long-term effects are still being counted today. And one of the most tragic legacies is the estimated 20,000 cases of thyroid cancer that were diagnosed in kids and teenagers. And this was almost entirely because they were drinking milk from cows that had been grazing on grass contaminated with radioactive iodine. And the financial cost? It was just staggering, an estimated $235 billion for the Soviet Union. This huge financial burden, covering everything from the cleanup to long-term healthcare, became this economic black hole. In fact, many historians believe it actually helped speed up the collapse of the USSR itself. But Chernobyl's legacy goes way beyond the Soviet Union. It's global. It forced the entire world to have a serious conversation about nuclear safety. It led to international oversight and massive changes in how reactors are designed. Today, a gigantic new confinement structure sits over the reactor, a monument to the disaster, designed to keep the world safe for the next 100 years. And believe it or not, the work there still isn't done. Incredibly, the other reactors at the plant kept operating all the way until the year 2000. The full decommissioning of the entire site is a slow, careful process that isn't even expected to be finished until 2028. In the end, Chernobyl is just this stark, powerful reminder of the very delicate balance between our own ambition and the immense power that we've managed to unlock. It really forces us to ask what we owe to the future and what lessons, written in the radioactive dust of Ukraine, we can simply never, ever afford to forget.